Hey guys, today I want to go over soil. As always, you can follow along with the guided notes here and in the PowerPoint that I gave in class. So the regolith is a layer of rock and mineral fragments that covers most of Earth's land surfaces. And soil is a part of the regolith that supports the growth of plants. And you can fill those in here. Then we're going to get to soil composition here. So there are four major components of soil composition. Those four major components being mineral matter, which is broken down rock, humus, which is organic matter and is decayed remains of organisms, so things like dead leaves and sticks, water, and air. You can see those here. These might be a little bit hard to read, but at 45% you have mineral matter, at 25% you have air, you have 25% water, and 5% organic matter. So moving along here. So texture is the proportions of different particle sizes, and there are several different types of textures here. We can talk about sand, which is the most common constituent of sand, is silica or silicon dioxide. It's SiO2 if you're talking about the chemical formula here. It is usually in the form of quartz. You have silt, which is a little bit smaller than sand, which is a granular material of size somewhere between sand and clay, whose mineral origin is quartz and feldspar. You have clay, which is a small size, and then loam, which is a mixture of all three sizes and is best suited for plant life. So we can talk about this here, the relative particle size. So gravel, which you can usually find in a driveway or something like that. You have sand, silt, and clay if talking about these proportionate sizes. Okay, this is a soil triangle, and I'll have another video on how to use this. Okay, so soil structure. Soil particles clump together to give soil its structure, and what we'll talk about here are the 5 important factors in soil formation. Okay, number 1 is the parent material, which can come from residual soil, or parent material is the bedrock, and transported material, which would be parent material has been carried elsewhere and deposited. And what I mean by parent material is where does this originate from? Okay, time is number one thing that's important in all geologic processes here, and the longer a soil has been forming, the thicker that it becomes. Okay, we have climate, which is, other than time, is the greatest effect on soil formation. Okay, time, all processes need those time, but climate has the greatest effect on these. Okay, organisms influence the soil's physical and chemical properties and furnish organic matter to the soil. And lastly, slope or steep slopes equal poorly developed soils, as it's hard to retain that due to erosion. The optimum slope is a flat to undulating type to which soil can pile up and produce healthy soils. And orientation or direction that the slope is facing, which would help with the soil temperature and the moisture that it's able to retain. Okay, so soil varies in composition. Moving on here. Varies in composition, texture, structure, and color at different depths. And you can see these here. We call those soil horizons, and they are zones of layers or soil. And a soil profile is a vertical section through all of the soil horizons. You can see that here, and we'll make one in class. Okay, Horizon A is commonly known as the topsoil, or right here. Horizon B is a subsoil and contains clay particles washed out from Horizon A. C is between the B horizon and the unaltered parent material, and then the parent material or bedrock is the lowest soil here. You can see a soil profile through all of these in this picture. There are 3 common types of soil. You have the petalfur, which is under forest, which is high in iron oxides. You can see all the different things about that here. You have the pedicle, which are grasslands and are high in calcium carbonates or organic matter. You can read all about that here as well. And you have the laterite, which is under hot, wet tropical climates. And these undergo intense chemical weathering because as temperature increases, so does the chemical weathering process. So water erodes soil. So increased rates of erosion due to human activities that remove natural vegetation, such as farming, lodging, and construction. And these greatly accelerate erosion. Here we have sediment deposition, which reservoirs will fill with sediment, and sediments are contaminated by pesticides and fertilizers in these and can lead to poor water quality. Okay, so how do we control erosion? Let me move my face up here so you can see it. We can add windbreaks, which are rows of trees that reduce wind erosion. We can terrace hillsides, and you'll probably learn about terracing as you go through your history class. And basically it creates steps as it goes down to limit water erosion. We can rotate crops, which deplete mineral resources in soil slower. We can contour our plowing, which you can see a picture of that there. And that's all I have for this PowerPoint.